see. See if this picks it up. We are talking about dimensional analysis. Dimensional analysis is just a way to change between units using conversion factors. Okay, a conversion factor is like 12 inches equals 1 foot. 1 foot equals 12 inches. Okay, or 12 dozen eggs. 12 eggs equals 1 dozen. Those are conversion factors. Okay, so when we are using it, we're worried more about units in chemistry, so this is where this comes into play. One of the things that I use in my class, and most chemistry teachers do, is what we call a railroad track. It is railroad tracks. It's just a bunch of fractions, but we put it in something that looks like a railroad track, and we make a fraction at the end and then divide. Okay, so we have some rules that go along with this. Okay, as I go, I'm going to touch on each rule, but I'm going to show you what we do. Okay, so for instance, if I had, let's see, 4 feet, and my question wanted to know how many inches that was, then I would just do it. I know you can probably do this in your head. However, we're going to do this in a chemistry method, which is what we're going to use most of the year, which is a railroad track. So I am going to take, this is what I call my given right here, and this is where my question is, what I'm looking for. How many inches am I going to need? Well, I can do this in one step. So what I do is I will do a set of tracks. I'll put my given here, that's rule number 1. Given goes in the top left corner, so I'm going to put 4 feet. That's what I was given. My question, and I forgot to put this in the rules, but I will have these rules available in class as well. So right here, you're going to have your question, top right. Okay? It doesn't matter how many tracks you have, it's always going to go in the last top right spot. So I'm just going to put inches. I am not going to add any numbers in here. I'm just going to start converting units. Now, I could put a 1 here. What I find happens is, in most cases in chemistry, when I put a 1 here, most students have issues. Now, you can put a number here if you're converting like miles per hour into inches per second, because you'll have to do the top and the bottom. But most cases in chemistry, we will only have one number converting into another number. But, so, for most cases, I don't like to put anything there unless it's like miles per hour or something like that. Okay? So, what I have on the top is always going to go to the bottom. That's what I mean by convert units. No numbers. I'm not going to worry about what the number is. I'm going to worry about what goes here, which is feet. Because I'm trying to get rid of feet and get into inches. Okay? Now, this little box right here, this little section right here, that little fraction, is your conversion factor. That is when you add numbers after you already have what you need. So a converting factor is something like how many feet equals an inch, or how many inches equal a foot. Well, we know that 12 inches equals 1 foot, or 1 foot equals 12 inches. So we put the 12 by the inch and the 1 by the foot. Okay, what happens next is the feet cancel feet, and all I'm left with is an inch. Okay, which brings me to the next point. Add numbers for the curve, multiply the top. I'm going to take 4 times 12, which is 48. And then I'm going to take whatever number it would be here, if there was one, times 1, which would give me a 1 and make a fraction. Well, then I'm going to take, and I'm going to multiply the top, multiply the bottom, which I did, and then I'm going to divide the top by the bottom. 48 divided by 1 equals 48 inches. And that would be my answer. Okay, so what if it's a little longer? What if I'm trying to go from 16 years into minutes? So what if I'm trying to take 16 years and I want to know how many minutes that is? Okay, well then I'm going to have to try to figure out, how do I go from years to minutes? So I'm always going to start with this track here, and I'm going to put in my given 16 years, and I'm probably not going to put anything here. I could put a 1. I would rather unite unless it's a miles per hour or some kind of per hour or per something. So what goes from the top has to go to the bottom. Now it says put in converting units. Well, can I go from years to minutes? Do I know a conversion factor for that? No, but I do know that how many days are in a year. Okay, so I'm going to put year here because what's on the top is always going to go to the bottom. Okay, and then I'm going to go to days. Okay, days. From days, I still need to get to minutes, so I still need another track. Days will go from the top to the bottom. And then from days, I can go to hours, because I know how many hours are in a day. So now, what happens is years have canceled, days have canceled, and I'm left with the hour. But I still need to get to the minute. So I can add another factor, another track, hours on top, now it's going to the bottom. And I'm going to go to the minute. So now, this is what I mean by convert units, no numbers. I converted from years to days, from days to hours, hours to minutes. Everything on the bottom got canceled out. Now I could put in numbers. Well, how many days are in a year? Well, there's 365 days in a year, so in 1 year. There's 24 hours in 1 day, and there's 60 minutes in 1 hour. Now, I would multiply the top, 16 times 365 times 24 times 60. Then I would multiply the bottom. Well, that's 1 times 1 times 1. That's going to give me a 1. Then I'm going to divide. If I divide anything by 1, I don't need it. So what I could do is I can get rid of any 1 that's in there, because if I multiply or divide by 1, it's not going to change my number. So I would just multiply the top. I would have nothing on the bottom. Makes life a lot easier. Okay? What if I did have 65 miles per hour? Per hour. And I want to know how many inches that is per second. Okay? Now, I'm not going to do the math on this because it takes too much time, but I am going to set this up because the whole point in dimensional analysis is if you set it up correctly and you know how to do the math comes easy. But here's one. Everything up here, I said don't put anything here. Well, here's a per hour. Per hour. So I would have 65 miles over 1 hour, because that's per equals 1. And then I would set up my factors. Now in this one, I have to convert both miles and I have to convert hours. I'm going to pick which one I want to start with, and then I'll do the other. Let's convert hours into seconds, because we know that that's a little bit easier to do. Well, if hours is on the bottom, this time hours will go on top, because I've got to get rid of it. Anything that's diagonal is going to cancel each other out. Just like year canceled year. Hours will cancel hours out. And I know that I can get it to a minute. So 1 hour equals 60 minutes. Now I put in numbers here just to show you, but I would do that, personally I would do that at the very, very end. Okay? Now that I have hours gone, because they canceled out, minutes can go on the top, and seconds can go on the bottom. Now why is this happening? Well, if you look here, inches over seconds. Here is seconds on the bottom. Here is seconds on the bottom, especially if I cancel out minutes. Okay? Now, I know that 1 minute is equal to 60 seconds. Okay? Now, I have already converted hours into seconds. Now I still got to do miles to inches. So, miles is on top, miles has to go on the bottom. Where can miles go to? Well, it could go to a foot. But I'm not in inches yet, so I have to do one more. I'm running out of board space. But miles canceled out miles. Foot is on the top, foot goes on the bottom. Feet cancel out, and inches go on the top. Now, I said the very last spot up top, right, is going to be your question. There is my question right here. But it took me 1, 2, 3, 4 places to get there. Okay? Now, I can put in how many feet. It's 5,680 feet to 1 mile, and 12 inches to a foot. So I would multiply the top and divide, and multiply the bottom and then divide. Okay, I'm making a fraction. I don't want to deal with ones, so I'm going to get rid of all the ones, because if I multiply by 1, it's not going to change anything. If I divide by 1, it's not going to change anything. So I'm going to just multiply. I'll do this one real quick. It's 65 times 5,680, which would give me, and I run out of board space, 369,200 inches over 60 times 60, which is 3,600 seconds. Well, I need to turn this into one number and not a fraction. So I'm going to take 369,200 divided by 360, or 3,600, and I'm going to get 102.5 blah, 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 blah. So basically, I'm going to get 102.6, I'll go for 6 and I'll round it. And I'm going to do inches over seconds per second. So it's 102.6 inches per second. Okay? And that would be my answer. That is converting through dimensional analysis miles per hour into inches per second. We're just changing between units using factors, things that equal. Okay? I hope this helps some, and we'll do some more in class. We'll actually get some practice, and we're going to do a lab with it as well. All right. Have a good night, guys. See how long it is. I don't want it longer than 10 minutes, but that's probably 10, 12.